Hey guys, how's it going? This is Simon, and this is the third of what will be 4 videos that I'm creating to help you prepare for Test 2 in the UNIX security course at Mohawk College. In this video, I'm going to be working on Module 4, which is all about security scanners and intrusion detection systems. So whenever you're ready, feel free to click on this link right here, which says Lab 4. Now, if you haven't checked out my first 2 videos, feel free to check them out. In the first video, I do explain that in these videos, I will go through the entire lab with you. The only thing I can't do is give you any answers to questions you have to submit to your teachers for grades. The other thing I showed you was how to prepare your VirtualBox Manager for these labs. And the quick version is you want to make sure the DHCP option is not enabled in the VirtualBox Manager. You'll want to make sure in Task Manager there isn't a process or task called VirtualBox DHCP or VBox DHCP. If you see it, just end the task and you should be good. And you want to make sure that your VirtualBox host-only network adapter is set to the right IP address and subnet mask, because we do want our host machine to communicate with our virtual machines back and forth. If you don't know how to do this, make sure you check out my first video because I do show you step by step. But if you do, go ahead and do that now, and whenever you're ready, go ahead and start your build server. So here's my build server. Whenever yours is loaded, feel free to log in as root and we can begin. Alright, so let's go down here to our overview. We can see a network diagram right here. We have our build server, and then we have 2 virtual machines that we're going to be creating. One is going to have a host name of N01, which is our Nmap server, and it has an IP address of 10.1.1.31. And then we have a test system, which is going to have a host name of Kenobi with an IP address of 10.1.1.32. So we're going to be creating these 2 things, and we do have some requirements. The requirements are that we're essentially going to have a standard Acme build. So we want to make sure that Alice is on both of these. We want the hostname set and the IP address set, and that's pretty much it. So if we go down to part A, build the servers, this is where we're going to begin, and we're going to look at the notes. The first one says you can use DHCP to assign the IP address and hostname if you like. So we're going to do that. That's something that I taught you or you learned from Lab 3. And if you don't remember that, feel free to check out my video. I am going to go through it, but I'm just going to go a little bit quicker than I did in my first video, which was all about Lab 3. So if you want more explanation about what I'm doing, or if you want a refresher, check out that video. But with that being said, let's start. I'm just going to minimize VirtualBox Manager. And what you're going to first do is go and edit the dhcpd.conf file in the VI editor. So we're going to say VI /etc/dhcp/dhcpd.conf, and we'll see this file. We're going to go right to the bottom and create 2 host blocks. So host N01 curly brackets, and it's going to be option host name N01 semicolon hardware Ethernet, and you're going to put a MAC address that you're going to assign to your virtual machine. So this MAC address that you're going to put in for N01 has to match the MAC address that you put for your N01 virtual machine. You can put whatever you want, as long as it matches. That's all that matters. What I like to do is this. I type in 08:00:27:AA semicolon, and then fixed address. We're going to have 10.1.1.31 semicolon, and we're done for N01. Let's do it for Kenobi as well. And we should be good to go as long as you have no spelling errors and you're confident with it. Go ahead and save it and close, and restart your DHCPD service. So we're going to say service DHCPD restart. I get 2 OKs, so we should be good with that. Now that you've done that, what you want to do is go into your pixielinux.cfg folder. So I'm going to say change directory to /var lib tftpboot pixielinux.cfg. That is the directory that we're going into. And if I type the ls command, we can see I only have 1 file in here that says default. We're going to use that. We're not going to create a new one, so that's fine. But just to get some practice in, we are going to link, we're going to make a symbolic link of the IP address to this file. So each of these IP addresses have to be converted into a hex format for this to work. Now, we don't know what the hex format is off the top of our head, so we're going to use a command that we learned in Lab 3, which is get host IP. And all you have to do is type in the IP addresses like you normally would, so we'll do 31, and we can see that we get some output, but at the very end we get our hex format of that IP address. So this is what we're going to end up using. So let's do it again for 32, and we get a different hex code, which the only difference is the last two characters. We have one F and two 0. And let's create that symbolic link now. So we're going to say ln-l default and then 0A01011F and 20. So if you've done that, you should be good to go. The last thing that we're going to do before we start creating our virtual machines is just editing the Kickstart file if we need to. So what I'm going to do is go into the VI editor and edit the file var www html kickstart default.ks. So if you edit this file, that's all you need to do. And depending on what you have might be a little bit different than myself. What I'm going to do is hit I to insert, and on the second line I'm just going to get rid of this host name. Now if you have Alice already, that's okay, but if you don't have Alice, then make sure that you add Alice into your Kickstart file. I'm going to go down here, and I like to put it under the skip X right here. So if you haven't done it, this is how you're going to do it. You're going to say user -- name equals Alice -- password equals user pass, and that's sufficient. You don't need to put in the group. In fact, I'm not going to put in the group just to prove a point down the road in this lab. I'm also going to put in Bob, but I don't believe you need to. So I'm just going to say Bob password user pass, and that's great. And what I'm going to do too, it doesn't require you to do this, but I'm going to put in or modify my host file so that it's easier for these virtual machines to communicate with each other using the host name. So I'm just going to go to the very bottom just before I have this hack to disable UDEV device, and I'm just going to append these host names and IP addresses to my host file. So this is going to look like this. You don't have to do it, but it might make things a little bit easier for you. So I'm going to say echo, and in quotes 10.1.1.31, and that's going to be N01. Append it to etc hosts, and do the same thing for 32, which is Kenobi. And I'm actually going to put in the build server as well, which is 20. And my host machine. You don't have to do this again, but I like doing it, and it's good practice. Makes things easier down the road. But whenever you're happy with this Kickstarter file and you've done everything I've just done, go ahead and save it and quit. And now that we've done that, we can now build our virtual machine. So go ahead and minimize this because we're not going to need this for a bit. Go to your virtual machine, click on new. We'll start with N01, and all of the default options are fine now. You can say next, next, create, next, next, create. Go to settings, go to system, and make sure that your boot order looks like mine. So it should look like this. If you have that, you're good to go with that. We can add a processor if we like. Then you can go to network, and you can change your attached to host only network. Host only adapter. Go to advanced, change your adapter type to fast3, and then make sure your MAC address matches what you put into that DHCPD file. So I started with 080027, and then I changed the rest of it to AAAAA for N01. And once you've done that, go ahead and start that virtual machine. And what I like to do is just make sure that it does work before I move on to the next virtual machine, because if it doesn't, then you might have to change something in your Kickstart file or your default file in that pixielinux.cfg directory. But so far it looks good. Usually for myself, I find that once you see the loading screen in that blue and gray screen, that's usually a good sign. So right here, we're just going to wait, see if there's any problems. And I don't see anything, so I think we're good. We're going to move on and create Kenobi. All right. And for Kenobi, I used BB. Start this guy up. Minimize the manager. And I think we're good. So I'll just scale this a little bit bigger to help you guys do that here as well. Just minimize this for now. We'll wait for this one to finish because it's almost there. And what we have to do just to complete part A is this step C, where it says install and map on N01. We're just going to run this command, say yes twice, and that will install and map on N01. We don't have to do this for Kenobi, but once you've done this, you have officially finished part A. So if you have any questions, if I'm going too fast, please leave me a comment. I'll help you out any way that I can, but I think that this is something that you probably are very familiar with by now, so hopefully this wasn't too confusing for you. But we can move down to part B. And this is all about using Nmap, and what we're going to do is we're going to scan Kenobi, and we're going to end up scanning BO1 as well. So the first thing that we have to do is first make sure that everything's running great. So let's just log in as root and make sure we have the right IP address. So 10.1.1.31, so that's perfect. And obviously if I say host name, we have N01, so this looks good. So I'm going to clear this, and what we're going to do is say yum install and map, yes and yes, and there we have completed part A now. So make sure you say yum install and map, and then you can move down to part B. And the very first step in part B is to make sure on Kenobi that we disable the firewall. So let's just look at Kenobi, see how that's doing. Looks like we're almost there. It's just going to load. Minimize this for now. And once again, we'll do the if config, just make sure the IP address is right and the host name is right, but we should be good to go. So sign in as root. Host name is Kenobi. If config is 32, so that's perfect. And we're going to stop the firewall by using service IP tables stop, which is the first step in part B. So service IP tables stop. And we got all OKs, so we're good to go. Let's minimize this for now because we're going to be using N01 for the remainder of this section. I don't think we have to do anything other than start the firewall later. So here we go. We're going to go to N01. I'm going to clear all this. And what we're going to be doing is working with Nmap. This is a really difficult part to kind of give you a tutorial on, or to kind of talk about in this video, because what we have to do is kind of figure out which command is the best command for some of these steps. So for example, 2 is where we're starting. It says run the simplest possible Nmap scan against Kenobi. So we've got this command, or we could use this command, and we can do both of them and we can see what it looks like, but we really have to understand both of them, and that's going to take a lot of time to kind of talk about, in my opinion. So what I'm going to do is try to make it as simple as possible. This command is basically the same thing as this command. We're saying nmap nvsl and then the IP address. I'm just going to use Kenobi because I've adjusted my host file, but you can use the IP address if you did not adjust your host file. Nmap VSL is the exact same thing. The only difference between these two is this N. So you're going to want to look at the man pages and figure out what is this N going to do differently than what this command does. So if I go into the man pages, which I have the website here, you can go into man pages in the actual terminal, but it might be a little bit easier to look at it on a web page. So I'm just going to quit this, clear this, and I'm going to show you. If I search for -n, we have it right here where it says -n, never do DNS resolution. So what that's going to do is it's going to make things a little bit quicker. you're not really going to see the difference in speed in my opinion, but you will see that you're going to get less output, and the output that you're going to see when you don't have the -n is just errors saying that it can't access any DNS servers. So let's do it together and we'll see the difference, and you'll see that this command right here is the better option for our lab. So I'm going to type in nmap-n-v-sl, and then I'm just going to type in Kenobi, and we get this little output right here, which is great. Let's do it again without the n. And like I said, it's not it didn't make any difference in terms of speed, but we can see a little bit of more information that says warning, unable to determine any DNS servers. We don't have any. Reverse DNS is, and it should say disabled. Try using system DNS. We don't want to do any of that. So when it comes down to these two, we know that this one is the better option. So let's move down to 3. So step 3 says let's find out a little bit more, run a simple port scan. This one is difficult to explain as well. The only difference between these two commands is this parameter right here, st and ss. And if you're like me, you'll look down and you'll see that obviously the teacher keeps on using st. So we see an st here, we go down here, we see an st here. So you think the answer should be st. That's the simple port scan, but what's really the difference between these two? And I have a website right here that kind of explains it a little bit better than I could explain it. Basically, if I scroll up to the top, we have what's called a TCP SYN scan, and that's the one that's SS. And it says it's the most popular and it's the default scan in Nmap because it performs quickly compared to other scan types. So you would think if that's the most popular, that would be the answer, but I guess he is saying run a simple port scan. So what makes this so fast? Well, what it does is it tries to make the three-way handshake happen to kind of do the port scanning. So it's going to send out a SYN, it's going to receive the SYN ACK, but it doesn't complete the three-way handshake. So it doesn't send an ACK at the end. So it doesn't use as many packets to get the information, so it's a little bit quicker, and that's why a lot of people like using this. But you need to make sure that you have root privileges to run this. So -ss requires you to have root privileges to run this. If you don't, if SYN isn't available, then you're going to be using the TCP connect, and that is your -st, and that's where any user like Alice could run this. So basically, I don't think you're going to see much difference in terms of speed, but I'm guessing that's why the teacher's using ST as opposed to SS, and that's, again, a guess. So if you have questions about that and you want more clarity, make sure you ask your teacher and they'd be happy to help. So let's run these two commands, see what it looks like. It's kind of neat, gives you some information. We're going to say nmap nv. First one is ST. I'm going to say Kenobi. And that was really quick. And we can see something here that says port 22 is open, so the state could be open, closed, or filtered. And it says service SSH, so that was really, really cool. Let's do the same thing with SS instead. And once again, that was just as quick, and it looks very, very similar to this. We see port 22 is open, state was open. Service SSH, so it doesn't look like there's too much difference between the two. There is a little bit, but for what we can see, it looks very similar. So again, I suppose the answer is ST, but I would ask your teacher about that just to make sure. So the next thing is, can we tell exactly what service is running on each of these open ports? And we don't have to compare anything, it's just giving us this command. So we know the nmap. N means we're not going to resolve anything. V is for verbose, and ST is we're not using the SYN, we're just using a TCP connection. SV means we're looking for the version of the service. So it's going to give us more information regarding the service. So see right here where it says port state service, we don't have a version column. When we add this, it's going to give us a version column. So it's going to give us a little bit more detail on what's open or closed or filtered. So let's just clear this. And let's put this in nmap-n-v-st and then sv Kenobi. And now we have a bit more information, which is cool. And as you can see right here, we now see the version of SSH, which is OpenSSH 5.3 Protocol 2.0. So that is really, really neat in my opinion. But that's all it does. It just gives you version, gives you a little bit more information, which is always good. So the next step is 5. Can we tell what OS is running? So as you can see, these two are exactly the same, except this command has this parameter, --os scan -guess. And what this is going to do is it's going to be more aggressive about figuring out what your operating system version is. So when it runs this, it's going to try to match your operating system with what it has, but by using this parameter is going to make it guess more aggressively, I guess, and it's most likely going to be a little bit more accurate than using this command. And if we go in here, we type in --os scan -guess, we can see right here it says it guesses the operating system more aggressively. So that's what it does. Let's put them both in, see how it looks, and type in nmap nv capital O and then Kenobi. So initiating OS detection, try 1, try 2, try 3. It's looking, gives us a bunch of stuff, and basically we don't really know what the operating system is. Sometimes it guesses it, sometimes it doesn't. OS detection performed. Basically we don't have that much information. So let's just clear this and let's try it with OS scan guess. So same thing, NV capital O, but I'm going to say --os scan -guess. So now look at that. We can see we have a little bit more happening here. It does guess something, running Linux 2.6.x. So it gave us a bit more information, and you're going to see down the line, I'm going to show you something else down here. It'll actually tell you that it did an aggressive scan of it. So that's kind of neat, but that's really the difference is when you're using OS scan -guess, you are going to be guessing more aggressively. It just makes sure it looks at all the matches and sees which one is as close as possible. So now let's go back to Kenobi and let's get that firewall back up. So go ahead and run this command in Kenobi. Wrong window. I'm going to say service IP tables start. All are okay. And it says run the simplest possible nmap scan against Kenobi. We've already done this, so we don't even have to worry about this anymore. We're just going to know that this is the command we're running with the n. So I'm just going to do that. Nmap nvsl Kenobi. And there we go. And then it says, let's find out a little bit more. Run a simple port scan. This one is a little bit different. This one has a T4. So that's the only difference between these two. But we are using the ST, like I said, so that must have been the answer for up here. But what is T4? T4 essentially will make the scan run quicker. So what I can do is show you in the man pages. There is a section, this T. And here it is. It says 0 to 5. So you can use -T 0 to 5, and it says timing template. So basically, if you use T 01, then I believe it tells you that it has to do with IDS evasion. Let me take a look. It does tell me somewhere. Let me just take a look. There it is. So right here, the first two are for IDS evasion, so 0 and 1, which is paranoid and sneaky. Polite, it slows down the scan to use less bandwidth and target machine resources, so that's 2. 3 is basically nothing. It's just the default, so it actually says that normal mode is default, and so T3 does nothing. Aggressive is going to speed the scans up by making the assumption that you're on a reasonably fast and reliable network. And then you have insane, and insane is assuming you're on an extraordinarily fast network or you're willing to sacrifice some accuracy for speed. So we're going to use T4, and as the only difference between these two, I don't think you're actually going to see a difference in speed, but that's the answer to this. You don't have to submit this, so I'm not giving you anything that I shouldn't be, but let's just look at this. Nmap NVST 10 point, or Kenobi. So a couple seconds, we're just waiting, and it's done. Let's do the same thing again, but we're going to add in dash capital T4, and we'll hit enter. So I don't know if that was quicker, maybe by a second, but that is the difference between the two. So again, I'm guessing that if you had a crazier network, or the machine was, a little bit more in depth than what I have right now, maybe it would actually be a lot quicker, but that is the answer to what T4 is. It's just going to scan it a little bit quicker. So now we're going to put it all together, and we're going to see a lot of cool information. So we're going to say nmap nv-A-T4, and then Kenobi, enter, and we'll wait. So this is kind of cool. When it says it's initiating the OS scan, you will see right here it says aggressive OS guesses, and it tells us what it thinks the Linux operating system is, and it says probably around 95% accurate. So it's kind of cool. It has all these options. You can see uptime, you can see a lot of different things. It's kind of cool. I would definitely check this out. This is something that might be beneficial on your test, because you might get a Trojan on your test, I'm guessing, because we're going to deal with Trojans down here, and you're probably going to benefit from checking Nmap and seeing if there's any vulnerabilities. So if you can, or if any ports are open that weren't originally open. So if you can get used to Nmap and you can kind of figure it out and put some time into it, it might be beneficial. I don't know, but I definitely think that if you get good with Nmap, that might go a long way in your career. So I definitely think it's something worth looking into. So now what we can do is we can move on to part C, which is just scanning BO1. So we're just going to run this command and see what comes up. So go ahead and say nmap-n-v-A T4, and I'm going to say BO1. And we'll take a look at this. And there we go. Once again, we got that aggressive OS scanning. It does tell you that it's just guessing. Yeah, just a bunch of cool things. Alright, now that we're done with part C, we can move on to part E, which is all about foundation skills. Sorry about the edit in the video. I had to go grab something really quickly, and it took a little longer than expected. So I thought instead of making the whole video over again, I was just going to make a simple edit, and here we are. I can't go over part D with you, unfortunately, because this is something you're going to get marked on. So if you do have questions about that, go see your teacher, and they'd be happy to help. But for the purposes of the video, we're going to skip ahead and move on to part E, like I said, and we're going to be working on the find command. So this is something that you're probably very familiar with, because we've gone through the fundamentals of Unix course. So you should know all about the find command. I'm going to go through this really quickly, but if you have any questions, let me know. First thing we're going to do is open a PuTTY session on our Windows workstation and SSH to Kenobi as root. So I'm going to do that right now. Let's just make this window a bit bigger for you. There we go. And now that we've done that, we can write a find command to find all files that contain the string rc anywhere in their name, and there's some hints. We're going to use the name parameter and put the file name in quotes to prevent globbing. So what we're going to do is this. We're going to type in find / for the root directory. We're going to say -type f to say we're looking only for files, because it says all files. And then we're going to say -name, and then quotes, we're going to say *rc* and end the quote. Once you've done that, you can hit enter and that should work just fine. The next step is to expand this by modifying it to perform a long file listing on each file it finds. So it gives us the command we're going to be using, -exec, and it tells us that it's really picky about the trailing \semicolon. So it's going to look like this. We'll use all of this again, but we're going to say space -exec, put in the ls command, ls-l, put that in empty brackets, or put empty brackets next to it, and then you can put your \semicolon. Hit enter, and there we go. That's how you do step 3. Step 4 says write a command to perform a long listing on all executable files on the system. So it says that we need to make sure that we find executable by owner, group, or other. So we got to make sure that at least one of these permissions, whether it's owner, group, or other, has an X in it. And how we're going to do that is we're going to be using the parameter -executable. So I'm going to just show you really quickly the man pages for find. When I go down here, we're going to find executable. So this matches files which are executable and directories which are searchable. So this is the command we want, or the parameter rather, but there is another one that we're going to use for the next step, and it's called perm. There we go, perm mode, and this allows us to search for specific permissions. So you can do perm mode, there's also perm dash mode or negative mode, there's plus mode, there's / mode, so it's any of the permission bits mode are set for the file. So there's tons of things here that we can still do, but for the purposes of this step, we're going to be using the -executable parameter. So let's just exit out of there, clear this, and then you can put it just before name if you want, -executable. And if you have something that looks like this, you should be good to hit enter. There we go, and we can see that there's at least one X in all these permissions, and that is what we're looking for. So finally, we're going to do step 5, which is write a command to perform a long listing on all set UID programs. Now, we're not going to look for RC, because if you look for RC, it's not going to come up with anything, and I'll show you. So how we're going to do this is, instead of executable, because we're looking for something very specific, we're looking for set UID, and that's not the same as executable. What we need to do is put in perm, and we're going to do / and the set UID is 4. So we're going to say 4,000. So it's going to look for anything with the set UID of 4, but these can be whatever it wants. It doesn't matter that it's 0, or if it's a 4, 5, 6, 7, it doesn't matter at all. All we need to know is that there is at least a 4, which is going to be a set UID bit, so you'll see in the permissions an S. But like I said, if I change executable to perm / 4,000, even though that's right and I hit enter, it's going to give me nothing. So get rid of -name, and that should fix your problem. So hit enter, and we can see now that we have a bunch of files, and we can see the S is there. So that is what we're looking for. He doesn't say that we need to make sure that there's the RC anywhere, but if you did put that in there, just remember to take it out, and you did do it correctly, as long as you had something that looks like this: find / type F perm / 4,000, and then execute the long listing. Alright, so that's it for the find command. We can move on to the md5sum command, and the first thing we're going to do is create a small text file named foo.txt and contain whatever thoughts that pop into your head. So let's do that. Let's just clear this. We're going to say vi foo.txt, and I already have one, and it says Simon is awesome, so I'm just going to quit, because that's sufficient for me. And we're going to run the md5sum on that file. So I'm going to say md5sum foo.txt. I'm going to hit enter, and we get a hash. So it's going to hash this file, which is great, but the next steps are going to ask us to change the contents slightly, run it again, and then compare them. So we're going to compare the hashes, and they should be different. So let's edit this, and what I can do is hit I and add an extra exclamation mark. And we'll save this, run the MD5 sum command again on foo.txt, and there we go. We can see that this, in comparison to this hash, is different. So even the slightest little change will change the hash. So that's really good. So then it says write a find command to execute MD5 sum on every executable in the file system. So we're just kind of, taking this and everything we learned and applying it to this. And it should be pretty simple, but just in case you don't know, it's going to be find / type F executable. We don't need name because it's every file that we're looking for. And then we're going to say -excc md5 sum, and then empty curly brackets / semicolon. And if you have that, go ahead and hit enter, and that works just fine. Alright, now we can work on the diff command. So what we're going to do is create a text file, bar.txt, containing a list, and it says 10 close friends. Just make a list, doesn't matter. We're just going to make sure we have something, a list for basically items on each line. So what I'm going to do is just clear this. We're going to say vi, and we want vi bar.txt, and I'll put in Sean, Devin, Josh, Zach, Bogdan, and that's sufficient. We're not going to go crazy. Save it, and then what we're going to do is copy that into a new file called bar_a.txt. And if we run the diff command, nothing's going to happen because they're the exact same file. So that's fine. That's what we expected. There we go. Nothing is there. So let's just change the spelling of one of our friends' name in that file and run diff again. So we're going to change the bar.txt file. I'm going to change Sean to Sean. Save it. And now I'm going to run the diff command on those files. And this is what we get. We can see that this file has something called Sean, and this file has another spelling of Sean, and it's spelled like this. Alright, so now it says add a friend to bar_a.txt and run diff again, and then we're going to remove two friends from bar_a.txt and run it again. So let's do that. So it says add a friend. So right here, I'm just going to add Alex. Run it again. Now we can see Sean is spelled A-W-N here, or S-H-A-W-N. And in this file, it's spelled the way that my friend Sean does spell his name, S-E-A-N. But then we also see that we have Alex in this file, and it's not in this file. So that's good. And then finally, we are just going to do one final thing, which is remove two friends. So, no offense, guys. There we go. Let's do it again. And there we go. We can see that technically we don't see Alex in here because Alex isn't in either of them, which is fine. But Bogdan is no longer in this file, but it is in this file. And then the spelling of Sean is different in each file. So that's how diff works. It's kind of neat, and we're going to be using that when we build our IDS. So now that we've done that, let's go down to part F and build an IDS. So what we're going to be doing is creating a folder or a directory under Acme Tools called IDS, and then we're going to be writing a script. So let's first make this directory. So we'll make the directory under Acme_Tools, enter, and then we're going to go into that folder or directory. I keep on saying that, but when I say folder, just remember I'm saying directory. And we're going to create this script. So we're going to say vi take_inventory.sh, put our shebang in there, so pound exclamation mark bin bash. I'm going to make a variable called my date, and the reason why is that we're going to make a file that is going to use year, month, day, underscore, hour, minute, seconds. And how we're going to do that is once I make my variable, it's going to equal $, and in brackets date plus %, year, month, day, underscore, hours, minutes, seconds. Okay, so what we have to do is we have to basically make a script that's going to create a list of key system files and their MD5 checksum. The file is going to contain the output of the MD5 checksum command for all executable files, not directories, and the entire contents of the /etc directory. Then what we're going to do is pipe it out and we're going to sort it. And then once we sort it, we're going to be storing it in a file called inventory dot and then our variable right here, whatever that comes out. So that's always going to change because every second is going to be something new. So how it's going to look is this. We're going to say find /etc type F executable. We don't care about the name. Then we're going to say exec md5 sum empty curly brackets / semicolon. And once you have that, we're going to pipe that over to sort, and we're going to put it in a file called inventory underscore $my date. So it's going to be in the IDS directory of Acme Tools, and like I said, it's going to be called inventory underscore my date. That's what all of this information is telling us to do, and once we run it, it should look like this. So let's just save this, make sure that we can run it as any user we want, and let's run it, see if it works. Doesn't look like it did anything, but if I type the ls command, we can see there's something. So let's just make sure that that is what we're looking for. Did it work? And it did. Not only did it do it the way that we were hoping it would do it, it actually sorted it as well. So we can see that if we scroll up, it started with zeros, then ones, twos, and it worked all the way down to F. So that is how you do it. That is perfect. And what we're going to do now is test it. So we've already run this. We're going to move here where it says make a small change to any file under /etc. So if you want, we can clear this and let's just make a new file. We're just going to say vi /etc, call it Simon is awesome.txt. Put whatever you want in here. It's true. Save it. Make sure you change the permissions so that it is technically an executable, otherwise it's not going to recognize it. And then we're going to run that script again. There we go. So run this script. There we go. And if I look at this directory, we can see we have 2 inventory files, and we're going to run the diff, and we're going to make sure that it recognizes that there was a change. So the first one is inventory 1150 and hit tab, and the next one was 1151. So we'll do inventory 1151 tab, hit enter, and there we go. We can see the difference is right here. There's a file called simonIsAwesome.txt. So that's perfect. That's all we want to do. There is a note that you might have some entries under proc that might give you some errors. You might find that it might complain about this, and it says it's safe to ignore that. Don't worry about it. I don't have it, and that's okay. It will still work for the rest of the lab. So we can clear this, and we can move on to the final part, which is part H, spy versus professor. We're going to skip this, and the reason why we're going to skip this is you have to do this with a friend, so there's no way that I can do it in this video with you. Essentially all you're going to be doing with your friend is trying to create backdoors into each other's system and see if you can figure out how he did it, what he did, how to stop it, or how she did it. So we're going to skip this and we're just going to move to part H, and this is where we're going to be downloading a Trojan horse program. There's technically 2 in there. And we're going to be putting it on Kenobi. We're going to run it and we're going to see if we can figure out what happened. So this is what we're going to do. First, we are going to download it. So I already have it downloaded, but I'll just do it again just in case. And it's going to download. If you're on a Windows 10 machine, you might find that it has a weird extension called Solitaire Theme 8. Don't worry about it. Send it to your Kenobi virtual machine, and we're going to change the extension later. It should say .tgz. So if it says .tgz for you, you're good. If it says Solitaire Theme 8, don't worry. I'm going to show you how to fix that. So once you have this downloaded, now you're going to send it to Kenobi. So go ahead and open up your command prompt. If you want, you can run it as administrator, and you're going to be typing in this command: P for putty, SCP, then wherever you've put that file. So mine's in users, Simon, downloads, Trojan, and that's fine. And we're going to be putting this on root 10.1.1.32, and I'm going to put it in the temp folder. There we go. So I can close this window, but I'm just going to leave it here for a couple seconds just so you can see what that looks like. So it was PSCP, your file, and you're going to put that root at the IP address, which is 10.1.1.32, :/temp. Alright, let's just check to see if it's there. ls, the temp directory, and we can see a couple things. Or a few things. We can see these 2 logs. We can see this yum log, and then we can see this file. So the first thing I'm going to do is change this Solitaire Theme 8 to tgz. So we can say mv I actually have to put it in properly. There we go. Just clear this. Now I'm going to extract it. So let's go into the temp folder, and we're going to say tar xzf, that file. And now we can see we have Trojan A and Trojan B that we can use. And the first thing that we're going to do is run Trojan A. So what we're going to do is this. We're going to type in ./Trojan A, and then -infect me with a capital I and a capital M. Hit enter, and it's going to give you a funny message saying thanks for running my program. If you ever need root access to your server, please let me know. And now it's messed with our system. So the first thing it says is have a look at the temp folder. So remember what we had here. We had this, and then we had this. We have all these guys. Let's see if there's any difference. So it looks like there's one file that's different, highlighted in red, and says temp_system.log. So we don't know what that is. It's telling us log in as Alice and try running this and see what we get. So let's do that. So I'm going to log in as Alice, and then I'm going to run it, and we get Vim. So it looks like it's a backdoor into Vim, which doesn't make sense. You're kind of like, why would I do that? Because I could have just opened up Vim by typing in vim. Why would I want this file here? So obviously it's doing something a little bit more than what you think it's doing. It's not just getting into Vim. There's got to be something that it's doing. So what could it be doing? Well, I'm going to show you what it's going to do. This was actually told to me by the teacher, so I didn't learn this on my own, but this is something that you have to look out for. You kind of have to think about your Unix administration skills and think, what could this be doing, and try to figure out how it's going to actually work. So I'm going to get out of here. I'm still Alice. Now, as Alice, I shouldn't have access to files that only root should have access to. For example, there's the file called /etc/shadow. and that's something that Alice does not have permission to access. Only root should at this point, because I've only created root on here with root's privileges or permissions. So I'm going to try to use this and access that file. So let's do that. /tmp underscore system.log, and we are going to say /etc shadow. So type that in, and when you're ready, go ahead and hit enter, and look at that. We can see the file. So that's kind of interesting. Let's just get out of this for a second. I'm going to type vim that file, and look at that. When I go through vim itself, I get permission denied, and it should be denied. But when I use this file right here, it lets me go in here. Here's another thing. When I scroll down, remember I added Alice and Bob as users. I never added anyone named Rhonda or Will. I have no idea who these people are. So now you have to think again, why is there some user named Rhonda and why is there some user named Will? What's the point of that? Is that going to do anything? Is that a big deal? Well, it might be. So let's check it out. What we're going to do, I'm just going to clear this. I want to see their IDs. I want to see what they're all about. So I'm going to say ID Rhonda. And look at that. The UID says 0. That means root. That means whoever logs in as Rhonda is going to have root privileges. They can do whatever they want. So this is a huge backdoor. This is a big deal. You can see groups, root. So Rhonda is basically unstoppable. So whoever put this on there, all they have to do is sign in as Rhonda, and they can do whatever they want. So that's a big deal. Let's see Will. ID Will. So Will doesn't look like it has anything to do with root. Actually, it just looks like it's Will. But here's where it gets interesting. You have these groups 503, which is Will. That's okay. But then you have 10, which is Wheel. And I don't know if you remember, but when I created Alice and Bob, I specifically said I wasn't going to use the groups. And when we ever put the groups for Alice and Bob in the previous labs, we've used Wheel. And what Wheel does is it gives you elevated permissions. So what this is showing you is that this Will account has some elevated permissions to do something. So that can be just as dangerous as well. So that's a big deal. But it doesn't stop just there. We do have another question. It says, can you find another file with the same MD5 checksum as that file that goes into Vim? So this is how we're going to do it. First, let's find the hash for that file. So we're going to say MD5 sum tmp underscore system.log, enter, and here we go. We have this hash, and we're going to highlight it and copy it. Now what I want to do is get every executable file on the system, and I want to compare it. So what I can easily do is this. I'm going to say find / for the root. Then I'm going to say type f dash executable, and then we're going to say dash exe c md5 sum empty curly brackets backslash semicolon. If you want, you can sort it, but put it into a file. So we'll just call it new.txt and hit enter. Okay, gave us a bunch of permission denied. Let's just see if it actually created it. It's because I'm Alice. We do have some file. So let's see if we found it. We might have to do it as root, but we'll check. So let's get into vi new.txt. So we do have a bunch of things here. Let's see if we have the one that we're looking for. We're going to hit colon, question mark, and then right click because you have your copy of the hash of this file right here, and hit enter. And look at that. These two have the exact same hash. So we kind of knew that this will probably have the same hash as Vim, but that just tells us that this and this are essentially the same, but this guy obviously is giving us permissions to do things that this one does not. So there we go. We've just answered all three of these questions. But it goes deeper than that, and you have to think deeper than that. And this is the hard part about trying to find how a Trojan is impacting your system. And this is going to be a hard part in the test. You really have to think about all the angles. So let's just go here and quit. Let's clear this. So let's do this now. We created this IDS, but haven't used it yet. So let's use it. Let's see what we can come up with. Is there anything else here that's not basically on here and telling us anything? So what I'm going to do is I'm going to go back into that folder, acme_tools IDS, and then I'm going to run that script again. Hit enter. Oh, I apologize. Let's get out of Alice. Let's do it as root. cd acme_tools IDS /take_inventory.sh, and we're going to hit enter. We didn't have any issues there. Let's just look. So this is the new file 1204. We're going to compare it to this file 1151. So let's say diff inventory 1151 versus inventory 1903. 1204. Hit enter, and look, there is something else that's messed up. There's this file rc local that seems to have changed compared to what it was before we ran the Trojan. So let's look at that. Let's see what it does. Cat etc rc.d/rc.local. The script will be executed after all the other init scripts. You can put your own initialization stuff in here if you don't want to do the full sysv style init stuff. Touch var lock subsys local bin sysconfig infect me. So it looks like what's happening is it's running this every time we boot into our user, and that just means we're just going to keep on infecting ourselves. So what we're going to do is just get rid of this file. So we're going to say remove, and we're going to say etc rc.d rc.local. Yep. Let's remove this file, the temp_system.log. So I'm going to say remove temp. Yep. And I'll leave the users in for now. I don't think that they're going to impact us negatively, but we're just going to remove those two files for now. If I type in ls, I don't see anything here. Let's say ls temp, and this is fine, this is fine, the new is fine, Trojan A and B is fine, this is fine, this is fine. So it looks like it's gone. Let's just exit out of root. Let's go back into it for a second. Okay, so it doesn't look like it came back. Let's just shut this down and see if it comes back after a shutdown. So it's just reloading. Okay, I'll log in as root. Let's check to see if that file's there again. So I'm going to cd temp ls, and it's gone. So it looks like we got rid of that backdoor. We still have Rhonda and Will, but if you go into the Unix administration, you can find out how to delete those users, and that shouldn't be a problem. So we can just assume that everything seems fine. We got rid of that backdoor, and hopefully it's just a matter of getting rid of those users and everything should be good. Now what we're going to do is run the Trojan B. And it says it's a little trickier. So let's do this. /Trojan underscore B, and we're going to say dash infect me again. Let's just look at temp, and what do you know? It's back, right? So that's back. Let's just cat shadow. We can see Rhonda and Will are still there. We never got rid of them, so technically we're not really surprised by that right now. But if we had, we'd be surprised because they'd be back. Let's just quit this. Oh, sorry, not quit it. We are going to try to run that script and see if the RC local file is changed as well. So we're going to go into the IDS directory, run, take inventory script, enter, ls. Now I remember that I used 1151, and we're going to use this new one that's 1208. So let's do that. Inventory 1151 versus inventory 1208. Enter. And here we go. We can see that it created an RC local file again. So let's just get rid of that. If we want, let's cat it just to see if there's anything new in there. So, yep, it put bin sysconfig infect me. So we're gonna just say, right, let's just get rid of this file. Remove. Yes. Let's go back to the temp and let's remove this file. Yep. ls. Wait, didn't we just remove that? Let's just clear this. Let's remove it again. Yep. ls. It's still there. So what is happening? This is where you have to remember, again, your skills from Unix administration. And one of the things that you can kind of figure out is, if you think about it, we are removing it. It is letting us. There's no error. So we're removing it, but it's coming back. So it sounds like, obviously, something in the system is just rewriting that file. And no matter how many times we remove it, it's just going to keep coming back. So what we're going to do is we're going to look at our processes. See if there's something in our processes that are running that continuously rewrites this. In fact, let's just see. Let's see if this comes back. There it is. This is back too. So obviously deleting this file and deleting this isn't cutting it. There's something else that Trojan B has that Trojan 8 doesn't. And if I say ps-efl, we get tons of things, right? What we're specifically looking for is something to do with this Trojan. So I'm going to say grep Trojan. And here we can see there was two things. So let's just clear this, make it a little bit neater. So there's two things. One here says grep Trojan. So that's what I just did. So this process doesn't really count. But the first one says there is something running called Trojan underscore B infect me. So it's a process that's running, and it looks like we're going to have to kill that before we can actually delete these files. So let's do that. Let's kill 9, and we're looking for 1635. We want to kill this process. Hit enter. Oh. There we go. Let's see if we can run this again. Alright, so it's gone. The process is gone. Now let's try to delete those files. So what we're going to do is rm temp underscore syslog, yes, and ls. It's gone now. Let's just go all the way back to where we removed this. yes. And if I type cat, no file exists. So this is what you have to do to basically figure out this part. Now this is something that you kind of are going to have to answer these questions down here, and I did kind of go through this with you, which I'm kind of giving you the answers, but this is a really important one to understand, is how you can figure out where the Trojans are, how they're impacting your system. You can't just assume that it's a file that they put in there, because it might be a file, but what's that file doing? Is it adding users? Is it giving permissions to users that it normally doesn't? Is there processes running in the background? Can you easily delete these things, or is it going to be something where you're going to have to delete the process first, then delete the files that it left as backdoors? So there's a lot to it. You really do have to think, and it's not easy. Technically, you can even use Nmap, and you can see if Nmap sees any ports that are open that shouldn't be open, that you didn't open before. So if we run this again, let's just run the Trojan again. There we go. So if I tip ls, it's all back. Let's go into N01. There we go. And let's see if we can figure out if it's impacted us with Nmap. -N, -B, -A, -T4, Kenobi, and I'm just going to put it through more. I don't see anything, so we might have got lucky there, but you never know. So you're definitely gonna have to look at a lot of different things, but that is how you can complete this section right here, part H. You're just going to have to run the program, look at the folder. You're going to want to look and see, how does this file that was added impact the system? Try to see it. Sometimes it's as simple as the file just does what it does, but sometimes you're going to look at the file and you're going to see, for example, Vim, and be like, well, that's not a big deal. And you got to think, well, why would they infect me with that? How is that going to actually impact me? Why is this here? Obviously this is going to do something different than what Vim is, because I would just use Vim, right? Then you're going to look and see, is there any other files on there that have the same checksum? And if they do, you're probably going to get an idea of what is being used as a backdoor. Also look at your IDS, see if there's anything that has changed, and we could see the rc.local file had a change to it. And I got rid of it completely. We should have just got rid of one line technically, but I just wanted to show you that it was going to get re-established after we put in Trojan_B. But you're going to have to look at that kind of stuff. Look at the users, look at their permissions. There's tons of things that we can look at processes. You just have to kind of get used to it. It's not an easy thing by any means, but when you go through this, try to do your best. Best thing that you could probably do is get your friends to do this section with you. Try to put files in there and try to do something that they're not going to know what it is, and they can find it out for themselves, and they'll do the same for you. And that's where you can really get a lot smarter with this, and you'll become more intuitive, and you'll become instinctually better at trying to figure out how these Trojans are impacting your system. So this, I'm guessing, is definitely going to be on the test. I don't know for a fact, but I can't imagine that we're not going to have this. So expect a Trojan or two. Expect that it's going to be difficult to find out how it's impacting your system. I guarantee you, if we do, it's not going to be as simple as this. So really look into this, see how this can, benefit you in terms of studying for the test. Hopefully this helped. If you do have any questions, let me know. But thank you for watching, and I will see you on the last video, which is coming very soon. Take it easy, guys. Bye.